So this side 10 I have mentioned, this side 10 I have not mentioned. So we will just add up when we are drawing the freeboard diagram for section 2. So this side is done. We just click the into mark and go to freeboard diagram. Free body diagram for section 3. So section 3 I am drawing. Okay, and there is a force P4 force of 16 kilonewtons which are acting. So the same 16 kilonewtons will be there this side. In order to keep this under, this member is under equilibrium. So here what you do is just add 16 this side, 16 this side. Okay, now already this 16 I mentioned in the freeboard diagram of section 3. Now left over will be this P3 and this 16. So here you remember, when you are adding this 16 this side and this 16, we are not going to change the physics of the problem. The physics of the problem will be same, because it is nothing going to change the member when you are adding two forces which are equal and opposite to each other. It will just cancel each other. But for our simplification only, I am just adding the 60 kilonewtons this side and this side, because it will be very easy when you draw the freeboard diagram of section 2, because you can have two forces this side and two forces this side. You can evaluate these two forces based upon sign convention. You can simplify it very easily when you mention like this. Okay, so when you take the freeboard diagram for section 2, so this is the section 2. So what are the forces acting here? 10 and another is P2. P2 is 34. So this is 10 and P2 is 34. And this side also P3. P3 is 40. And that side is 16. That side is 16. So the resultant this side will be 34 minus 10, 24, and here resultant will be 40 minus 16 equal to 24. Okay. Now when you draw the freeboard diagram, overall freeboard diagram, you see the direction is this one, this is 24, and here also this should be direction 24 kilonewtons. Okay, this is the freeboard diagram for section 2. Now it will be very easy. Further you can calculate the change in length for the individual sections, and you can just add it up for getting the overall extension. Okay, this is how you can calculate for any problem. You try to solve the problem number 22.6. Okay, there is a problem number 2.6 in BC Punmiya book, which I shared you through Google Classroom. 2.6 and 2.7 also, example 2.7. It is a solved problem. It is very easy, and it is just mentioned the vertical direction. That's it. In remaining things are same. Okay, right. And try to solve this assignment. Try to solve this problem, and I will mention example 2.6 also, because it is somewhat different. Example 2.6. In example 2.6, see, the bar is given in this direction. This is the bar. Okay, so there is a force of 20 kilonewtons which is applied at B, and there is a force here 30 kilonewtons, and there is a force here 40 kilonewtons. D, C, B, A, and this is 0.75, this is 0.5, and this is 0.75. These are the lengths which are in meters. Okay, now the problem is same. You have to find out the total elongation of the bar. So, but here if you see, this bar is fixed at point A. When it is fixed, there will be a reaction force, right? So there will be some reaction force when you draw the freeboard diagram of section 1, 2, 3. So when you draw the section 1 freeboard diagram, so there will be some reaction force which will act here, isn't it? So but we have to calculate. We don't know how much is the reaction force which is acting at section A. So this is the when you draw the free body diagram of total bar. So I'm taking the total bar. So here it is B, C, 40, 30, 20. So there will be reaction force here. This is the reaction force which is R, which is acting vertically upward at section A, because it is supported, right? It is supported means there is a reaction force from the ground. So this reaction force can be calculated. R equal to, so this is upward force and these are all downward forces. So R equal to 20 plus 30 plus 40 equal to 90 kilonewtons is the reaction force which is acting on the top, because this upward force should be equal to the downward force, right? Your total downward force equal to 20 plus 30 plus 40, so it is 90 kilonewtons. So this is the reaction force which is acting at the section A. Now remaining thing is same. Now you take the section 1 separately, section 2 separately, section 3 separately. You draw the free body diagram for section 1, section 2, section 3 separately, and you calculate the total extension of each member. Okay, so try to solve this also. You have to calculate total extension. Total length is 2 meters, and Young's modulus you take 2.05 into 10 power 5 Newton per mm square. Okay, try to solve this problem. Okay, by this concept we have finished the principle of superposition. Okay, thank you.